Hello, my name is Colin Doyle. I'm a senior consulting engineer at Juniper Networks, and welcome to the 10th video in my Apstra and EVE-NG lab series. In the last video, we updated the configuration for our DCI links in each of our fabrics so that the traffic would be tagged. This allowed us to configure new connectivity templates so that we could provide connectivity from the tenant 1 routing instance that all of our virtual networks, our host subnets, are connected to, and provide access and connectivity to the what we would call a core network, essentially putting the routes to these hosts and these host subnets down here into the routing tables that are on these routers. In this lab, you can see there are no hosts that I have, aside from this WAN sim we'll be using today for internet connectivity. There's no hosts that I could test to that are connected to this core. Rather than test to those hosts that don't exist, we created a default route with the next hop discard here, and we advertised that into the fabric. The way that we verified our simulated core / WAN connectivity was working was to ensure that we had that default route down here at the border leafs in that tenant 1 VRF that these hosts are connected to. Those hosts get a default IP address. Actually, we set it because we just manually configured it. We're not running DHCP here. And that default address will hit the IRB interface on these leaves in that tenant 1, and then the default route will do the work from there. In today's lab work that we're going to be doing, we aren't going to touch Apstra or modify the fabrics at all. Our work in the fabric is complete. That is why now more than ever, it's very important to focus on the intent of the tasks that I'm going to take you through versus going through and trying to do this step by step in your own environment. You obviously have a lot of flexibility for implementing connectivity to the public internet in your own environment, and this video is intended as a guide to sort of help give you the basic fundamentals of what those steps are going to be. I'm going to do things like set up NAT. I'm going to have OSPF. You don't need to do NAT. You could use a different routing protocol. So adapt these instructions for your own environment. Our first step is going to be configuring this WAN sim. This is going to act as a gateway for the lab to reach my internal home network, the firewall that I have in front of my lab. It's going to get a DHCP address that I will ensure never changes. I've got a static assignment already configured on that firewall that's upstream, the physical box that's on the other side of the wall here. And it'll get a DHCP address and a default gateway on this GE002. We'll then take that default gateway here and we will advertise it via OSPF to these 2 external routers. From there, we will create a routing policy on these external routers that will advertise that default into BGP. We'll also remove the static discard, obviously, or else that'll break stuff. One consideration for me that is something you could do differently, I've decided to set up NAT here on this firewall. Now, obviously, I'm running NAT in the firewall that's connected to my lab that eventually goes out to the public internet. So this is a double NAT situation. The reason I'm going to do that here is to cut down on the amount of steps that I need to take today. If I didn't do that, I would need to set up another routing protocol relationship with that lab firewall that I have. Not super complicated, but again, it can do just to take this discussion and the work we're doing today even further beyond the virtual lab and into a space where it's unlikely that anybody watching this is going to have exactly the same firewall with exactly the same configuration. It gets really esoteric at that point. If I use NAT, then all the traffic that originates within my lab appears to come from a single IP address going out to that other firewall. This will allow us to connect to the public internet very quickly without a lot of extra configuration. The downside is that it only allows connectivity to the public firewall. I'm essentially creating a relationship between my lab firewall and my firewall here, this WAN SIM that is in the lab. That means that if I have other computers or hosts that are in my own home network that I maybe want to connect into the lab hosts with, I can't do that. What IP address am I going to go to? I can't point it at the NAT address that is on the WAN SIM. I could set up other forms of NAT, but again, this is a reductive exercise in trying to give us minimum viable connectivity without getting into too much of these other use cases. So if you want to do this differently in your lab, if you want to build a protocol relationship with some upstream firewall so that you do have reachability to those testing hosts to other physical devices that exist outside the lab, or if you want to set up some static NAT or one-to-one or destination NAT, you can do that as well. Out of the scope here, we really just want to focus on getting connectivity to the internet. First things first, let us build our WAN SIM. I'll open that up and I'll drag the window over here. As always, I have documentation that will take you through step by step all these set commands. I will type them out here. I greatly encourage folks to follow the links in the description to the Juniper Elevate community, where there's a thread for this video that will include the documentation. Log in, set system root authentication, plain text password, as always, Juniper with a capital J. Set system host name. I remembered the dash this time. If you watched the other videos in this series, I had to pause a number of them to add the dash into the host name command. And then I had to go update the documentation everywhere else. Now, we get to use one of my favorite commands here, wildcard.
And I'm still the wild card, so that's good.
No.
If you're not familiar with this command, it can be a huge time saver. I'll do a wildcard range, and this simply tells the Junos operating system that I'll be using a range within the set command. After this, it's just set security zones, security zone trust. I can't run this in packet mode because NAT's going to require state interfaces, and here comes the range GE-00 bracket 0 through 2 close bracket .0 for the sub interface, and it works. It's really slick. Wildcard commands are awesome. Security zones, security zone trust. We have to enable the capability to accept, not drop OSPF control traffic, so host inbound traffic. Protocols, I could actually say OSPF here, but I'm just going to say all. Again, reductive exercise, tune this to your needs. And we're going to do the same command, and we're going to say system services. And this is essentially me setting the capability of the control plane to receive and not drop traffic. So this isn't a zone-to-zone thing. This is things coming into the zone where the destination is the firewall. Any service, great. Set interfaces, GE000.0, family, INET, address 10.100.200.1/31. I'm building my transit networks to my external routers here. Set interfaces, GE001.0, family, INET, address 10.100.201.1/31.0. The other side of the transit net will be on those routers. Great. And set interfaces, GE002.0, family, INET, DHCP. This is the interface that faces my core network. Fun fact about VSRX, it has historically had some challenges with DHCP, being a DHCP client. I'm using the most current version on juniper.net, so I would recommend you do the same. I initially built this lab, and for this particular node, I used an older version, and it was a giant pain in the butt. Let's make sure this works. Interface is TERS, GE002, and it did get an IP address. And if I do a show route, I should see a default route that it says access internal. That just means that it has been received via DHCP. And I think there's some other cases where you'll see that, but in this case, that's what we've got. So that looks terrific. We're now going to configure NAT. We're going to get to use more wildcards, which is terrific. Set security. I'm going to build address books. Oh, I've gone out of my config, of course. Set security. These address books will help me define the source subnets, the virtual networks that I'm going to be natting. So set security, address book, global address N101, 192.168.101.0/24. And I can go up, and I'm just going to go back, and then VN 102, 192.168.102.0/24 up, and then 3 192.168.103.0/24. Wildcard range set security address book global address dash set virtual dash networks, and this is the term that we'll reference in the NAT policy address. And here comes the wildcard range. Rather than have to type these all out, EN10 bracket 1 through 3, and those are the networks that we just created up here. These, and this wildcard right here allows us to define the range and not have to type it 3 times. Not like that would take a long time with the up arrow, but this is actually more an exercise of making sure the set commands fit in one slide versus the amount of time it takes. Okay, set security NAT source rule set SANT from interface. This isn't a range. This is just a representation of an iterative set of interfaces. So I could either GE dash, you want to have a space after that, 0, 0.0, GE dash 0, 0, 1.0. I could also just do 2 set commands and it would look like that identically, one after another. But again, I want to fit it all into one slide in my documentation. Set security NAT source rule set SNAT2 interface. This is the outbound dash 002.0. That's what faces my lab firewall. Set security NAT source rule set SNAT rule R1 match source address dash name virtual networks. Got to type that out. Can't tab that one for some reason, even though we did just create that. Set security NAT source rule set SNAT rule R1, then source NAT interface. Great. Commit and quit. Show security NAT source rule R1. Okay, so anything that originates from these interfaces will be pushed towards that interface. We're matching this address set, and we're doing an interface NAT. Basically, it's an overload. It does that by default. You don't have to tell it to do a port address translation. Now let's configure our connectivity on our routers. Right, configure, set interfaces, E00, 3.0, family, inet address, 100.200.0/31, quit. And if you want to, you can just do a quick ping, make sure this works. Hey. All right. And this one. Configure, set interfaces GE003.0, family, inet address, 10.100.201.0/31. Commit and quit. Boop. And why not? Just for good measure. 10.100.201.1. Perfect. Exit. Oh, wait. Ha! Exit. Force a habit. Don't need to do that. Only 4 more slides, but they are densely packed. I'm going to go back into router 1. I guess I could have done these both at the same time. And I'll show you actually something neat. It's not just router 1, it's going to be router 2. So I'm going to open up router 2. If you're using secure CRT, and this I'm only going to do this here because the configuration for point-to-point OSPF that's going to go onto these routers is identical. I'm going to right-click this. I'm going to say Send to New Tab Group. That's essentially going to split the screen. If I go down to this box at the bottom, I can say send the commands that I type into all sessions and then send them immediately. And as long as I am typing, when I say typing, you won't see the text, but in this box down here, if I click into this box, you'll see that there will be a blinking cursor when I do that. I'll click in this box and I'll hit enter, right? Configure, and we're just going to be able to put these commands in at the same time on both routers. First step, let's delete that static route, routing options static. We do have a ASN in there, so don't delete the routing options entirely, just the static part. Delete policy options, policy statement, export default, because we're not mapping this anymore to a static. So term default from, and that will delete the part of that policy that references a static specifically. Set policy options, policy statement, export default, term default from protocol OSPF, the route filter of 0.0.0.0/0. I think I could also just type in 0, and I'm going to say exact. Great, enter. Suddenly bumped the caps lock key there, sorry. Set protocols OSPF area 0 interface. You know what, before I do that, let me just show you what that policy looks like. Show policy options, policy statement, export. That's what it looks like now. All right, set protocols OSPF area 0 interface GE00 3.0 interface type point to point. Point to point means that there's no DR, designated router election, that the traffic that is sent as unicast, not as multicast, because it's just a relationship between two devices. Wildcard, range, set policy options, prefix, list, virtual dash networks, 192.168, and bracket 1-3 close bracket .0/24. So neat that you can do that. Set policy options, policy statement, export, nope. OSPF, because we need a different policy for this. Term, virtual networks, virtual dash networks, then accept. Oh, sorry, I cut out of sequence here. You wouldn't have the accept first. That doesn't make any sense. We need to have a from command. From protocol BGP. You know what? Let me start that command over for you. I got a little confused there because I jumped down in the bullets of my instructions. Set policy options, policy statement, export. I tabbed this out and then it backed up so I could type in OSPF, term, virtual dash networks, from protocol BGP, prefix, list, virtual dash networks. Set policy options, policy statement, export OSPF, term, virtual networks, then accept. And then we're just going to go back here. Default action. We're going to set a default action here, then reject. In the absence of a from, it will match everything. Set protocols OSPF export OSPF. Show policy options, policy statement, export OSPF. This is what that policy statement looks like. From BGP, it matches that list. And this is going to ensure that we're exporting only the host subnet, the virtual networks for our host in our fabric up to that WAN SIM. We don't need to be exporting anything else from these routers. Great, commit and quit. And now we need to configure OSPF on the WAN SIM. Configure. I am using DHCP. I have a note here. All right. So if you're using DHCP for your WAN IP and default gateway, which I am doing, the first thing you need to do is set policy options, policy statement, OSPF underscore export, term default from protocol access dash internal route filter 0.0.0.0/0 exact. If you recall from the when I showed this, and do run show interfaces. Route. When you get a default gateway like this from a DHCP server, it shows up as this access internal here, right? If you have a static IP address, then having a protocol export filter for access internal isn't going to work for you. So what you would need to do if you have a static address is you would need to first do a set routing options static route, right? Route 0/0 with the next hop that is whatever your upstream firewall is, right? That's the first thing you do. And then the second thing you do is you would have a protocol that said static here. That would be the difference, right? So you would need, if you have a static IP address for your WAN upstream link that goes to whatever your external device is that you're going to be routing through to get to the internet, change this to static and make sure you have a static route. I do not, so we're going to delete that. Set policy options, policy statement, OSPF underscore export, term default, then accept. This is very, I think, identical to the other one that we did on the routers, except for this part right here. We did protocol BGP. Now we need a default action, set policy options, policy statement, OSPF export, term, what is this? Default action, yeah, default underscore action, then accept. Great. Wildcard range, set protocols, OSPF, area 0, interface, GE-00, bracket 0-1. These are the interfaces connected to the routers. Interface type P2P. Set protocols, OSPF, area 0, interface GE002.0, passive. This is the connection that goes up to the external firewall that I have. It's passive because we're going to use it as part of our advertisements, but we're not going to be sending OSPF hellos. Set protocols, OSPF, export, OSPF, export. Great, commit and quit. Boop. To recap, and we'll bring those back up in a second to test. We have set up an OSPF relationship between these devices. We have put BGP route filters on our routers to ensure that we are advertising and exporting only the virtual network subnets from our tenant 1 routing instance. We have configured OSPF policy to only advertise a default route down towards the routers. And we have modified the BGP export policy that goes down to our border leafs on that link that we created that goes directly into tenant 1 through that connectivity template to advertise that default but down into those that tenant. So let's do some checks and verifications, and all of this is in the documentation as well. Just so you know, if you download the documentation, you'll have access to all this. Show route 0 exact. Great, we see that. Show route protocol OSPF. You can see that we have these. I should have another one. That's interesting, because I don't see 102. Hang on, here's a show OSPF neighbor. That looks right. I wonder if it just hasn't activated, or maybe I didn't type something incorrectly. Let's check one of these. And you. Might as well just bring you all up. Let's see, show configuration policy options. Yeah, that looks right. Show route 0/0 exact. Okay, yeah, that looks good. Show route advertising protocol BGP 10.3.0.10. Oh wait, I am looking at the wrong. Let's see. Show BGP summary. 12, of course. All right, so advertising a default down into the, that looks right. This is going into the fabric. I'm going to go to one of the leaves and just make sure I see that. See that default down here still? Show route table tenant 1 inet.0. There it is. Great. Let's just let's swing for the fences here. Test. Hey, come on. Test 1, 2, 3. I don't believe that I put a browser on each of these. I was having TLS issues, so I know one of these I updated. I don't know that I might have to do a little work on this before it works the way I want it to. Let's see. Google.com. And we should also be able to ping 8.8.8.8, which is our DNS. All right, so we do have internet connectivity from here. Let's jump over to this host in VN103, because that was the one address that I didn't see. It might just be that I need to generate some traffic here. Ping 8.8.8.8. I mean, it's clearly working, so looking good. Open up Firefox and let's make sure we can browse. Not the hugest amount of resources on these, but probably worth the wait. Open up Google. Huzzah. Looks great. Cool. Apstra. Juniper. I mean, it's working, so I don't think we need to wait for this very resource-starved host that I have to resolve that. That is it. That is the last of our day ones. Oh, there it is. See, came up eventually. That's the last of the day one videos. The next video is the last video. It is a day two operations video where I'm going to cover some common scenarios. Maybe not common, but I do want to show you how Apstra behaves when it encounters issues, or what it refers to as anomalies. I can even explain why they're called anomalies and not, what's a problem. And show you how we sort of interpret the information that Apstra presents us to drive towards a resolution. It's an amusing experience for me because you can't just break Apstra. It won't let you commit configuration that damages the fabric and disrupts the intent. So I actually literally have to turn links off in order to simulate problems, which is great. I mean, that should be the way a data center functions, right? Thank you for watching. I hope this has been informative. If you have any questions, again, click the links in the description. Ask those questions over in the Elevate community. I'll do my best to answer them. I hope you have a wonderful day. I'm going to record this last video, hopefully before my family wakes up, and then I'll start editing and we can wrap this up. Take care.